Welcome, friends, to yet another podcast on precast structural design engineering. We did a podcast a couple of weeks ago regarding a multi storied parking building in precast, and we looked at the various design aspects that go into making that kind of a structure. So today we thought we'll take up another structure which deals with static loads. Last time we dealt with a dynamic load structure, which is a parking structure. This time we thought we'll deal with a static load structure, and we have once again with us my colleague Mangesh, who is willing to spare time. Welcome, Mangesh. So it's very difficult to get you off the chair and get you here. So thanks for being with us once again.
Yes, thank you.
So how are you?
Fine. Very.
And okay, uh, we discussed about the parking building last time in precast, and yeah, I've seen you again doing a lot of different kind of structures in precast elements. And very recently, we completed a data center building in precast for a client in Nigeria. And if I'm not wrong, the building was quite large. It was about 220,000 square feet, and I've seen you spending a lot of time on the design engineering, and then of course we had the detailing team which did the rest of the work. So, tell me, what are the prime considerations when we talk about a data center building in precast?
Basically, it's data center is a kind of server containing structure. So it contains lot of servers. Server loading is there. Basically, server loading is not given anywhere. We have to not even the codal provisions. Some codal provisions have it, but still we have to check it. Like, what is the server load? So it's given directly given by the client that this will be the load, and accordingly we have to design it. So it's nothing different from other structures, but the load is very specific. Like many commercial building has its own load provided in the code. For the residential it's different, but for this server data center it's specifically given by the client.
Yeah, because if I look at the difference, if you look at a mall or maybe a school, there is still a lot of dynamism. In fact, the load keeps varying on the
Yes.
slabs. And in case of a data center, we have a huge heavy server which is static at one point, and the load keeps continuously acting on the element. Okay. So, what are the elements that were used for this particular building?
Elements were hollow core slabs, beams, pre-stressed beams, and the columns. And for the core, staircase core and the lift core walls, RCC walls, structural
Okay.
walls.
So the columns were not in precast as far as I remember.
Yeah, they were.
So what is the reason that columns are generally cast on site? I mean, I've seen this in many structures, except for the Middle East where people are, habituated to using all the elements in precast. So what makes it different with the other regions? I mean,
Basically, this type of structure is called hybrid structure, where cast in place as well as concrete precast is used. In some cases, steel also is used. This kind of structure is kind of needed just because the site conditions are like that. In this project, Nigeria, it was like this. Like the columns were very heavy,
okay.
so casting was taking time. So instead of wasting the time in erection as well, we decided, like all the site people and the factory people decided not to go for precast one. We decided to make it cast in place. Simultaneously, when columns are casted, we can cast more number of pre-stressed beams and hollow core slabs. So that was the condition.
So technically, you didn't lose any time in because of the columns being cast on site. And the reason you're giving is okay, the columns are quite huge, and there could be crane capacity constraints.
Yes, that will be
And
also one more thing.
yeah, so we have to look at the commercial feasibility of any structure as well.
Yes.
Yes. So the columns were cast on site, and the other elements were being made in the factory. And by the time you started the actual work, most of the elements
Were on
were
the site
on
itself.
the site itself. So the purpose of having.
Curing was done as well as it was stacked on the site. lots of elements. The columns, first level columns were casted, were going, casting was going on, and other elements also from the second floor and third floor, elements were on the site
Okay.
after curing.
So the purpose of using precast as an option for construction was not lost. Okay,
Yes.
so we could exploit all the advantages of precast. Now coming to these, the other two elements, the more important elements, the hollow core slab, which was pre-stressed, and the beams also were pre-stressed. Uh, how did you go about the design engineering of the hollow core, for example? I mean, let's start with the hollow core.
Yeah.
So, how did you go about it? What exactly goes into the design aspect?
Yeah. You mean to say what softwares we use, how the analysis
And the
was going on?
calculations, then what kind of software tools you used?
Actually, what we did, like there were two type of analysis or design we did. One was software calculation, and that software calculation was validated using manual calculation.
Okay.
First of all, what we did is like we did all the pre-stress designing in pre-stress software, and from that we took those forces and tried to simulate it in Fame software using the 3D frame. As Fame design doesn't use hollow core pre-stressing unit, so we applied it as a diaphragm. uh, Slabs were applied as a diaphragm, and we checked the beam forces, like moment and shear forces, were they matching with the forces which we got from pre-stress software. So this both validation was done, even manual calculation was done. All this came in one point. We decided like we can go for this design. That's all.
Okay. And is it necessary to validate using manual calculations? I mean, is there any reason why you do
Yeah,
that?
basically when we start with the design, we first of preliminary think about like this should be the deflection, this should be the moment coming around, and we also gave certain kind of sizes of the beams, so it should match with what we are thinking. So like we have experience, a certain amount of experience. On that basis we have certain amount of intuition that this will happen here. If it's not happening, something is wrong in our calculation, or it's something wrong in the software itself. So we
Okay.
have to check, continuously go on looping in this pattern while we are designing it and
Okay.
analyzing it.
So this applied for the beam also. The same process that you did for the hollow core was also done for the beam.
Yes.
Yeah, okay. And see, what I've heard is these servers are kind of immensely heat radiating equipments. So, are there any special design considerations for the heat management? Because structurally, I can understand, but for heat management, is there any design consideration for the data center?
Heating is like we have a rating for heating, like we expose the element for 120 minutes, and on that basis we decided the cover of that element. Like that cover is like distance between the outer face of the element to the reinforcement.
Okay.
So on that basis, like for this project, the exposure condition was 120 minutes, like kind of 2 hours.
Okay.
So 2 hours it was going on for heating, and on that basis, on that rating, we decided to take 50 to 75 cover for each and every element.
Okay, this I think you're talking about the fire instance, maybe.
Yeah,
But in general, also, the server tends to emit a lot of heat.
yeah.
So, are there any specific kinds of walls that are required for the structure?
No, structurally it was not needed, but there was a block wall which was
Okay.
used, and I've heard about this many my client saying that we are going to apply some certain insulation around the walls. So we had to consider the weight as well, and that was very light insulation material they've used.
Okay, so they kind of saved on weight using a lighter insulation
Yes.
instead of going for maybe a sandwich insulated wall.
Yeah.
And that was perhaps not in your scope because the
Yeah.
insulation part was done by them.
By the
Okay,
client.
okay, okay. Yes, so that was as far as the heating aspect was concerned. And the explanation of the 75 thickness that you gave, the cover aspect, was for the fire rating.
Yes.
So if there's a fire that goes on continuously unattended for 120 minutes, the elements will still hold
Yeah.
the structure intact.
Yes.
That's what you're saying.
Yes.
Yes, okay. And Coming to the aspect of the structural stability of any precast structure, joints are very important. So in this case, you are talking about something which is quite heavy, 20 kilonewton per meter square. So what kind of joints were considered for this data center?
Basically, Nigeria is a seismic zone region. For the hollow cores were considered as a diaphragm. So diaphragm action was there. So if the diaphragm action is there, so we have to transfer all the diaphragm action to the beams uniformly. So the connection between the hollow core slabs and the beams were kind of opening the core, giving the reinforcements, shear reinforcement, and that was transferred to the beams. Most critical was the beam column joint. Basically, we have standardization in beam column joints, like plus kind of connection, where the column is there and four columns beams come intersect at the column top, and third condition is like three beams come in the on the column, and for fourth condition was like minus kind of. So in these conditions we have typical kind of reinforcement protruding out of the beam. So in this project we had a very criticality, like each and every joint was not standardized. Like uh, when we took one plus element plus kind of connection, it was different from the other.
Okay,
So that was the critical part in there. And the second thing, the reason because it was so critical, because of the reinforcement clashing, and we could have avoided, but we could not use corbel there.
okay,
So why we cannot use corbel? The reason is like a client said that while installation of servers, it will come in middle. We want a clear height, so he requested not to use corbels.
okay, okay.
So that become more critical.
So which means the reinforcement would have been really compact,
Yes,
and there would have been a lot of
clashing
clashing or entangling of the reinforcement from the
reinforcement.
columns and the beams.
Yes.
And what was the reason that each beam column joint was different? I mean, which is
The reinforcement of the column was different at each and every element, every point, and it was heavy. Similarly, the beams were different. Even if the grid size is same, but we had a certain condition of different in orientation of hollow cores. So the column reinforcement differ each and every joint.
okay.
So lots of difference there.
Mhm. So you mean to say the load was not uniform all across the structure?
Not load, but the reinforcement arrangement
Okay, okay,
which we had used. It was not standard everywhere.
okay. And I mean, you said something about the alignment changes with the hollow cores or the hollow core slab. So what
E-
was the purpose behind that?
yeah, the reason is there was one column. Like when we have a data center, mostly it's in a same line, same order. The coordinate system is like uniform, like 10 meter 10 meter grid is there.
Hmm.
But in this condition it was very different because of certain other storage was also there in that data center. So same in the same building.
Hmm.
So that's why there was a lot of orientation, offsets in the columns itself, and it was so critical that we had to change the orientation, and even to lessen the amount of beam reinforcement and the heavier beams, we had to change the orientation. The orientation changes was also due to the heavy seismic condition
Ah,
which
okay.
were helping, or it was adding the heavier section for each and every beam. So we had
Hmm.
to change a lot of things.
Hmm.
This was the second thing. Third thing was a lot of changes in MEP
Okay.
conditions. So there were a lot of cutouts. So to avoid cutouts in the loading itself, we had to change the orientation of the hollow cores.
So was that the reason why this design phase was extended quite a bit? Because yeah, generally we have seen projects coming and going very fast. I mean, we have seen the team doing it really fast. But in your case, I remember that there were some revisions in
Yes.
designs, frequent revisions in designs.
Yeah, the reason is like a lot of cutouts were changed,
Okay.
and the critical condition was like that, like the here the cutouts were so large, we had to suggest the client to use a casting place slab itself.
Okay.
That was the main reason, and because if we cannot transfer the load through the hollow core,
Yes.
we had to have certain solution. So we had to change orientation. Where there is no we cannot have the solution, then we had to go for casting place. Like those casting place slab was like this, like it will carry the load on both the sides. Two-way kind of slab. Hollow cores are generally one-way slab. For the casting place, we went for two-way slab there.
Okay, so the moment a cutout becomes large,
We
the
had to go
strength of
for
the element also reduces.
reduces.
Yeah, so for that you had to improvise and use something like a cast in place. So it was truly a completely hybrid structure. Okay, so the columns were not precast. Okay, then there were MAP changes and you had some cast in place situations as far as the slabs are also concerned. And how many storied building was this? I mean,
Uh, Four.
four storied, and the columns were uh, cast
Casting place.
in place
Right.
for all the floors. Okay. One more thing. I mean, one thing is there for any structure. I mean, there is always a dead load, but there's this for a dynamic structure. I'm asking. There are vibrations. I
Yeah.
mean, even if it's a mall with a huge footfall, we do take it into consideration. So for the server, is there any kind of vibration which you need to consider?
In the server, it's there is vibration, but that was considered in the 20 kilonewton per meter square, which was given by the client.
Okay.
So it was kind of heavier load which they had given.
Okay.
So that's why starting I said that they have to do critical checking for the server load. There they did it like if it is coming around 10 kilonewton per meter square for uh, the server itself, then it should be double it. So that's their approximation by doubling it.
Okay.
So that is their tech, like what heavier structure we want. So there was not like whole of the structure was not 20 kilonewton per meter square. There was a load which was 11 kilonewton per meter square as well
Okay.
in certain places.
But the structure was rated for 20 kilonewtons
Yes.
as a blanket.
Yes.
Okay. And is there any codal provision for that region? Because Nigeria is in Africa. So, what codes do you normally follow?
Basically, Nigeria has its own local code, but it has its own limitations. So we most of the client there basically use a mixture of codes, Eurocode and ACI code. Priestess I generally preferred for PCI handbook. I went for a lot of references was taken from there, and design was done on the basis of Eurocode.
Okay. Okay. So, I'm sure, I mean, this would have been a very good learning experience for you, this particular project. And I remember it went on for quite some time.
Yeah.
So, frequent revisions would have added to our knowledge base as well.
Yeah,
Okay.
lot of.
So it's good. I mean, very interesting. So next time, I think we will come up with yet another type of structure.
Sure.
So we'll continue with the commercial buildings for some time, and then let's see if we can do some discussions on the residential design also.
Sure, sure.
So till then, I think I'll wish you all the best for your current project, and
Sure.
look
Thank
forward
you.
to see you soon.
Yeah.
Yeah, thank you for being here.
Yes, thank you. It's pure pleasure.
Yes, so friends, we had yet another interesting podcast. The purpose, as I said, is to come up with technical discussions which are more supported with some kind of illustrations wherein we give a glimpse into the design engineering aspect, which is very difficult to convey in a blog article or a case study on the website. So I hope you all enjoyed it. And in case you have not seen our first podcast, we have included the link in the YouTube description. So please make sure that you have a look at it as well. Thank you very much.